Hi everybody, my name is René. I work at 5Minds. We're an IT consulting and software development shop in Germany specializing in process-driven architecture. And I'm just highlighting my employer here because they support me in going to events like this. And I think we need this support by our companies in order to fulfill our mission to see more Elixir software in the world. Speaking of software, I'm René on Twitter and GitHub. And some of the software I created includes Credo, which is a code analysis tool, and Inch, which is a documentation analysis tool. Funnily enough, I won't be talking about either of those, but rather something more fundamental, which is flow and process. And just so I don't disappoint anybody during my talk, this is not Flow, the Elixir library. What flow should mean in the context of this talk is the way data flows through our programs guided by business logic and control flow representing a business process, which we are tasked to implement. And there are many interesting topics around this, like validating your inputs at boundaries or which data to persist along the way. And while we will touch on these subjects slightly, I would really like to focus on the flow part. So we're looking at business processes like this. We'll use this very straightforward example of a little image conversion task throughout my presentation. This is a very straightforward process, just consisting of 5 steps, but the techniques we will use to implement this process will be getting more complex over time. I also brought this real-world example from one of our projects, where you can see how it's all about moving and transforming data. It's moving data over networks into databases and onto hard drives, and transforming data, which usually means expanding and reducing it, and it often also means change semantics along the way, and hopefully some value added in the process. There's lots of possibilities to move and transform data in Elixir, because, as somebody once said, it's just modules and functions. On a personal note, this whole business of moving and transforming data is something that I find much easier in a functional environment rather than an object-oriented one. But even in Elixir, it's not all rainbows and sunshine, because human problems remain. Different developers use very different approaches to naming and nesting and formatting parameters, and we have to take care that the general interfaces of our flow don't become too diverse. Parameters are suddenly named differently across the code base, signatures get clunky, documentation gets outdated or is neglected from the start, and if it's just one function that is documented or named or structured badly, that's not a problem. But when all the functions are, it is. So how can we avoid these problems? Well, we should always aim for clarity by reducing uncertainty for the programmers. We should communicate intent both with our code and our data structures, as flowing data structures oftentimes represent intent. We want to create a structure that's flexible enough for changes, but still rigid enough to work as a guideline, because we want to take care that the code is accessible, especially to new team members. Creating maintainable software should always be the highest goal. And fortunately, this is where Elixir can help us, because there are language constructs and best practices which mitigate the mentioned problems, and these are pipes, the with macro, and the token approach. First, let's talk about pipes, because you probably already know that one. This is a pipe, and this is an answer to a problem. It's an instrument for building pipelines, which are a series of pipes where one function's return value is the next function's first input. And this is not a new concept. You're probably familiar with it from shell programming, from Bash or PowerShell. Piping something into the next process is pretty much old school. So back to our example process. The little image conversion tool we are going to write with its 5 steps: parsing the command line arguments, validating these arguments, preparing the conversion, actually doing the conversion, and reporting the results. We can see how this is probably a pipeline. So let's implement the mix task for it. This is what the run function of our mix task looks like. And if we look closely, we can find all the 5 steps in there. Let me highlight those. Now, this is all very good, but maybe we could make this flow even more obvious using a pipeline. And when putting these steps into a pipeline, we get one of those pieces of code where I'm regularly thinking, oh geez, I could show this to my manager and he or she would probably get it. Because if we highlight the steps like before, it becomes obvious why. The 5 steps from the diagram are right there. So are we done? Is this it? Let's do Q&A. What's the downside of this? Well, each function's return value has to be accepted by the next function. If we look at the functions, we can see that the signatures have to match the return values. This becomes more obvious when we highlight them in different colors. And now you can see how the yellow return value has to match the yellow function parameter. The yellow return value is the result of our validate the inputs steps. And if we wanted to return something else, like a validation error, then we would have to add a function signature matching that return. So the advantages of type lie in that the flow becomes very obvious at the top level. And the disadvantage is that all the signatures have to match all the possible return values from the step before. This can get fuzzy very quickly, especially when we talk about error handling. And this is one of the reasons why the with macro exists. The with macro is an answer as well. It is made for those complex scenarios similar to the ones we can deal with pipes, but where the APIs of the different functions do not deliver exactly what we need for the next function. So this is a tool of choice when constructing flows that involve third-party functions outside of our control. This is how our original example would look like when we refactor it using the with macro. And once again, let me highlight the steps from our flow. They're all there. And one thing that is nice about the with macro is that we can write an else clause to catch any unexpected return values outside the expected patterns. So for example, suppose our validate options function might not return an OK atom, but in some cases might return an error tuple. We can add an else clause to match all the unexpected return values. And this is something we could also have done with pipes. But it would have been much more cumbersome. And more importantly, it would have been less visible at the top level. Because now we can not only see our 5 steps, but we also see all the things that are anticipated to go wrong in our flow. And the one obvious drawback here is that if 2 functions return the same kind of 2-element error tuple, then we won't necessarily be able to differentiate between these 2 within a single else clause. So, which one's better? Well, pipes enable pipelines, and they are very useful for high-level flow. They can be ideal in situations where you control all the interfaces and where you can dictate the rules and just let it crash and burn when the rules aren't met. The with macro, on the other hand, is a Swiss Army knife, great for the nitty-gritty low-level flow interactions where you call third-party code or code by other teams or libraries that don't quite fit into a coherent interface. So in the end, this is not a question of being better, but rather a better fit for any given situation. And there's a third option, which I'd like to call the token approach. This concept is very loosely related to the context design pattern and command pattern in OOP, and even more loosely related to the concept of Elm architecture and the flux pattern in JavaScript. And I think the best way to describe what the token approach is to talk about popular examples from the Elixir open source community, which are Ecto change sets, plug connections, and Wallaby sessions. With Ecto change sets, we're creating a change set by casting. In this case, a user struct, parameters to change the user, and a list of attributes that can change. And then this change set is our token. And that token goes down a pipeline. We're working with this token, which represents our intent to change data. A plug connection, on the other hand, represents a request to our web server waiting for a response. We can modify the answer while the token goes down a pipeline. We can put the response content type, add response headers, and send the response with an HTTP status code. Or we can even halt the pipeline to prevent the execution of further plugs on an individual connection. Here, the token represents the user's intent to get the requested information. As a last example, we can create Wallaby sessions which allow us to test our web services. So in a way, these are the counterparts to the plug connection. And this time, our token goes down a pipeline as well. We can visit a path on our server, we can fill in some text fields, click a button, and make assertions on the response. Here, our token represents our session on the server. So I think you're getting it by now. A token is basically a struct that's handed down during the execution of a process that's handed down a pipeline. But why is it called a token? Well, the token approach stems from a board game analogy. And I wanted to explain that analogy using this beautiful photograph of some Chinese gentleman playing a board game. But then I realized that I am not really that sophisticated because I don't even know what that game is. And since you should only talk about what you know, I will explain it using the Game of Life board game. So the token in this game represents you, moving around, taking different paths along a fixed set of branches. And the token also represents intent, to get an education, to get rich, to win the game. And the token also represents resources, which are transformed along the way, like your family members, your bank account, your action cards, etc. And that's why it's called the token approach. And because context was already taken by Phoenix. So, how do we design our own tokens and token APIs? Which fields should be included? How should we name each field so the meaning becomes obvious? Let's find out by designing these things for our little image conversion tool. So here we have it, our first token. The fields on this one are the arguments supplied via the command line, the file glob, target directory, and the image format, as well as the file names to convert and the map for the results. So this token will have all the information needed to fulfill our business case. This is Token API 101. You will always want to have a build function in your token API because this way you can ensure that the token you create is valid from the start. In our example, we want to make sure that the argv field is always a list, which we do with a guard, and we always want to put a default image format. Next to building tokens this way, you will also want to create functions for writing to them, since this enables you to validate and normalize your inputs. The image format is a great example for this, so we will add a put format function to our API. In this function, we validate the given format against the list of allowed formats using a guard again, but we can also normalize our inputs because some people weirdly prefer to write JPEG with an additional E, and using an additional function signature like this, we can accommodate those users with very little overhead. Let's see how this works. So first, we build the token, and the format is, as expected, JPEG. When we use our put format function to change the image format to PNG, we achieve the desired result. And when we try to change it to JPEG, but write JPEG with the additional E, that works as well. This brings us to the last point, which is providing convenience functions driven by the business process. So the file glob, the target directory, and the image format are the combined result of the second step in our business process. And because of the fact that these only make sense together, we want to provide a function to write, validate, and normalize these options at once. In this example, we put in the format first because that operation, as we saw, can fail. And then we put in the file glob and the target directory after the fact. Now, this is not super important in this contrived example, but the order in which validation and normalization operations are applied can matter in less trivial cases. And what we want to avoid in any case is that the user modifies the struct all by himself. Not only does the above example look less nice than the bottom one, it also denies us any possibility for validating these inputs, and it chooses the order in which the values are put into the token, which again might not be convincing in this example, but in other examples, the order in which you apply these operations might be an actual concern. So, what are the tips for designing your token and token API? Well, you should always design your token around its intended use. And you should design your token APIs around real requirements and not around how fancy the code might look like. Use your token API for creating the token, so it's in a valid state, and use your token API for writing values to a token so it stays in a consistent state, because you're able to validate and normalize upon writing. And you should provide these these convenience functions for common operations, because if at any point you need to restructure these operations, you want to do that in your API, and you don't want to ask your users to update their application code. So, here comes the fun part. Let's talk about meta-programming our own custom pipelines. The leading question here is, what if I wanted my own plug pipeline? Well, this example won't work. It won't take us very far because we can't use the plug macro in our command line tool, since a plug takes a plug connection as a parameter and returns a plug connection. But what if we write our own macro and we'll call our macro step, since these modules will be steps in a business process? Speaking of modules, yes, we are now switching to using modules instead of functions. And the modules we register here have to adhere to a certain behavior so that we can call them. Let's have a look at that behavior. A step is just a module implementing a callback named call that takes a token and returns a token. Now let's see what a single step looks like. This is the first step in our business process that parses the options from the argument given to the mix task. And it is pretty straightforward. We're just using option parser to get the options from the argv list and set some default values. And this is the complete module unabridged. But we can focus on these 3 lines to see how we are registering the behavior and implementing the call function, which takes a token as its only parameter and returns a token. And naturally, this is already functional. We take a couple of arguments, we build a token, and then call our new step module converter pass options. And what we get back is what we would expect, a valid token with all the relevant fields filled in. Now, this is the trivial part. What we want to define is defining pipelines using our step macro, and we do this by using a builder module. And using this builder module will give us our step macro. And the step macro will have to ensure that all the registered steps are executed subsequently and that each of them returns a token. So let's see what that macro actually does. The using macro inside the step builder module looks like this, and there are a couple of interesting things here. First, this import statement ensures that we can use the step macro inside our application, inside our pipeline module. And if we look at the definition of the step macro, then we can see that the step macro is really simple. It simply writes the given module to a module attribute. This way, the macro calls in the comments at the top yield the module attribute declarations at the bottom. There's just one problem. If we look at the bottom, at first the steps module attribute has the value converter pass options, and then the value gets overwritten with converter validate options. To prevent this, we have a line in our using macro where we register the module attribute with the option accumulate true. This way, the values of the module attribute are not overwritten, but rather accumulated. Let's see how that works using this example. We register the module attribute to be accumulated and then subsequently assign 3 values to it, A, B, and C. And at the bottom you can see that we get the list of attributes in reverse order since new values are prepended rather than appended to the list. So we have our list of steps. All we have to do now is generate the call function. And as you can see here, our call function calls another function called doCall. And that function does not exist yet. We will generate it using the callback we register with the before compile module attribute. The before compile callback is called, you probably guessed it, before Elixir compiles the module. And what happens here? We're reading the steps from the module attribute we wrote them to. And in the next statement, we're using the steps to compile the body of our function. And then we are inserting the resulting doCall function into the pipeline module. Let's look at this compile body function. Looking at this function, it is important to remember we are building an AST in quoted form in all of these functions. So how does this work? Well, our initial statement is our token, and you will see why that is in a minute. And then we use enumReduce to iterate over the steps, which are in reverse order, and build our pipeline. So it's enumReduce, reverse order list, starting with the last step, we are working our way inside out. And this is done by the compile step function. Now, compile step takes 2 parameters. The current step from the reverse list of steps, and since it's used via enumReduce, the accumulator as a second parameter. In the first line, we are reading the call to the current step module into a variable, and then we are unquoting the current call into the head of a case statement. And within that case statement, we are matching on the result of this call. If we get back a token, we continue with the already compiled statement. If we don't get back a token, we raise an error. All of this might be easier to comprehend using this very simple example. Our pipeline consists of the 3 steps in the top right corner, appropriately named step 1, step 2, and step 3. And we start our process with the initial statement, which is our token. Upon the first iteration of enumReduce, we add the case statement for the last step. Remember, the list is in reverse order, that's why we are starting with the last one. You can see here how there is a call to the module step 3. The whole case statement is wrapped around our initial statement. And upon second iteration, step 2 gets wrapped around the already compiled statements. And with the third and final iteration, step 1 gets wrapped around the already compiled statements. And that's all there is. It's a bit like those Russian Matryoshka dolls, which are nested into one another. And it doesn't do much. It calls the current steps, it matches on the token. If it doesn't find a token, it yells at us. And as a side note, this is very fast code. This is really what you would type out if you were crazy about performance and had a knack about typing repetitive things. But thanks to metaprogramming, we don't have to type it all out by ourselves. And even better, we can now do pretty much anything. Although we probably shouldn't. If we look at our compile step function again, we can generate any source code we want here by modifying the case statement inside the quote block. So for example, we could add special logging to the results of each step. We can add it right here after the token has been returned from the current step and before the already compiled statement are unquoted. We could use a similar approach to add debugging capabilities or record metrics of the execution speed of each step in production. We could also introduce a halt mechanism similar to the one present in Plug, which would enable us to leave a pipeline early. And we would do this by adding a new field to our token, which we could call halted, and then we would match on halted true in the case statement. If that match is successful, we just return the token, effectively skipping the rest of the pipeline. And here we are only executing the already compiled statements when we encounter a token with halted false. And to turn it up to 11, we could even expand our step macro to allow for conditional flows, where we add another syntax to the step macro that not only takes a module, like in the first line here, but that it can also take a do block with conditions, which it checks before executing the relevant path. So, when should we use this dark magic, especially since the first rule of metaprogramming is don't use metaprogramming? Well, you should have a clearly stated requirement. For example, when you have to ensure contracts are met between the business steps, or when you have to be able to add things like additional steps or universal halt mechanism or metrics or reporting later on. Remember, metaprogramming can help you ensure such a consistent flow, but you can have a token and token API without metaprogramming, because as we discovered, it's just modules and functions. So, some final thoughts on the token approach. I just told you that you don't have to use metaprogramming for everything. Well, you also don't have to use this token approach for everything. There are scenarios where you probably want to avoid it altogether. For example, when there are very few stakeholders and to define a data contract just seems unnecessary. Or when you have very many stakeholders, but the requirements are still vague. You literally shouldn't sign a contract, not even a data contract, when you don't know what you want or need. Also when the problem domain is very small. For example, imagine we have a web service and we're trying to make a login attempt with email and password. That's just one context in which we talk about this tuple of information. We shouldn't want to introduce this because the overhead would simply not be worth it. And remember, this is not a one-size-fits-all solution. Now, when to use this approach? Well, if many parts of your system have to talk about the same thing in different contexts, this is great. For example, after our login attempt is successful, in many systems what you then get back is some kind of identity. And you will use this identity for this user, which probably contains an email and claims in a claim-based security system or roles in lots of parts of your system to authorize actions, to contact the user, etc. So sometimes the need of a contract is apparent and simply outweighs the overhead of yet another struct. Also, you want to use this when you have several data pipelines in your business or when extensibility is a major concern, when you want to add steps later or monitoring or logging or a plugin mechanism, or I think you get it by now. So these are the 3 key takeaways from this talk. Think about the flow of your program. What is the thing you're talking about and what are the essential steps? Make that flow as easily comprehensible as possible for new contributors, new team members, and your future self who hasn't looked at that code in a while. And the major takeaway regarding Elixir is that there are several options to cover the most common cases all the way up to creating your own version of a plug pipeline. If I got you interested in this topic, I wrote a blog series on architecting flow in Elixir, where we also implement all the examples I showed you, what we could also do, like the step macro that takes a do block and the conditions. And this is published on my blog at develop.de, which is also linked in my Twitter profile. And for some further reading, I'd like to recommend this article by Alex from Dockyard on using the with macro, and this presentation by Laszlo on robust data pipelines from the last ElixirConf in Europe. And that's all I had. Questions?
Can you just go back to the previous slide?
Yes. I think on the left, there's a gentleman.
Do you have the token API extracted into a library for reuse for other folks?
So that's typically the first question one gets when talking about this, but I don't think that sort of a plug for everything makes sense, because you always have those business-specific use cases. You always have to, it wouldn't make much sense to have some kind of macro that builds up a struct for you containing like 1 or 2 common fields, and then you have to add your own business case specific fields later on anyway. Anyone else? You all want to get to lunch early, right?
Hi, I was wondering if you had any quick thoughts about if you were using this token-based design for a flow where the flow can conditionally branch. That's something that using the with construct, for me as a new Elixir developer, I've sometimes struggled with, if you wanted to skip a step, for example, depending on a condition, that can sometimes make a with construct a little bit more verbose or less clear. I might have to break things out into functions. So I'm wondering if you have an example with a pipeline that might be less linear, how you would handle those branches using this construct.
Yes, so in the blog series, there's an article which shows exactly that, which goes back to basically this, because what this really is that the condition token.errors equals an empty list is actually an option to every step macro below it, like step, converter, prepare conversion, and then if colon that. And you will see in the blog post how that works.
Great, thank you.
So the with example that you had, and you were like saying like you can't figure out which one through the error. Like,
Yeah.
There's a useful trick you can do there. If you, on the right side, if you embed it in a tag tuple, you can match that same tag tuple on the left side, and then also match the error with the same tag. It's a pretty common trick.
Okay. Probably we should talk later,
Okay,
and you
sure.
can
Yeah, it's
show
useful.
me.
If people don't know it, it's useful to know.
I'd be glad to incorporate that.
Hi. You mentioned ensuring the consistency between each flow step, and I noticed that you, in the macro, you were showing just raising a runtime error. Do you think there's any way to introspect on the AST passed in to provide more compile time guarantees that each step in your flow actually conforms to the contract that the token pattern is expecting?
So I'm not sure if I'm understanding what you're asking. So basically, you could say this step needs a token that is like this, structured like this, and for example, a certain value is not nil or something. Well, you would basically be able to code that using just functions and guards. So I get that you asked for a compile time guarantee, but I'm not sure how that would work.
Neither do I. I was just curious if it was something you given that thought
but
to.
I'm trying to make it up on the spot, and it doesn't work. Because in the compile time, in the before compile macro, you just get the context of the current module, which is your, okay, yeah, I also had that slide, but no matter. Right here. So this is where we get the before compile, and we get this env parameter, and that env parameter only contains the current module. But for what you're asking, we would have to look to other modules for the ones that are referenced and get their AST, and then have a chance to put some guarantee there, like a bit like a type spec, maybe, where you could say, I just want tokens like this. I should take note of that. Maybe we can do that.
Thank you.
Yeah, just piggybacking on Connor's question. I think you can implement behaviors, right, for those modules that would take this step, right? Each module defines a function that follows the same signature. So you could define a behavior, and then at compile time, it would raise a warning. And you can actually extend that. You could actually fail compile by the way you fashion your macro. You can cause the compilation to fail, but that's pretty involved. But at least you can get the warning if you don't follow the contract of the behavior.
So you would just add the inside the behavior, you would modify the callback directive. Is that what you're proposing?
Well, each of these step modules, yeah, they implement that call. And if they don't implement that call properly, then you're going to get a compiler warning. Yeah.
You're right.
And you can actually write a macro to fail compile. In addition to just a compile warning, you can actually fail compile. But that's more involved. It requires a lot of explanation.
I'll probably look into that. That is a very interesting topic.
So there are errors during the pipeline. Do you have any tips for how you would figure out which part of the pipeline had an error, and maybe if you would be able to recover from it, if at all, later in the pipeline?
So I'm not sure if I'm understanding you correctly. So if we don't raise, but rather recover, or what is the thing you're asking?
Yeah, so say if there was an error when you're trying to validate the options or something, but it's a specific case that you can handle later on.
So you basically would want to have it skip some steps, or you would have... One thing I experimented with was having multiple pipelines, because pipelines are basically also just steps. If we look at this backup slide, the pipeline is also just called. It also implements the call behavior. And what we could do if we had something like this halt mechanism, we could say that at the start of a pipeline, we would implement a custom call, which first resets the halted flag, and then calls the generated function __ do call. And at that point, you could insert something like, we want to report the errors. So you could have an error pipeline and go on pipeline at that point. But to be honest, that's one of the examples where it's probably the overhead is not worth it, because then if your fingers are itching because you find metaprogramming so fulfilling, then you you have to hope that somebody at your company starts an intervention.
Okay, thank you.
Hi. Do you have any generic advice, heuristics maybe, or potentially good ideas for token design itself? You showed some examples of having an errors field or a halted field. Are those good ideas in general? I know the answer is always it depends, but do you have any advice anyway?
So I would just look at the popular libraries like Ecto change sets, for example. There's a lot of stuff in there that I still don't comprehend. But I think, knowing Jose, it probably makes sense at the end. So he would probably be the person to ask. But because, for example, a change set has a field that's called action. And there you have insert, update, etc. And when you call the update function with an insert change set, it breaks. But I'm not sure when that would happen. But that sort of is one of the... I'm rambling. Because I don't know the answer. I don't want to say it depends.
Have you thought about with this pattern enabling ways for people to inspect what the step pipeline is going to look like at any point? So an example of this is in Phoenix with plug, where you can have plug, use the plug macro across many files, and I may want to drop in at some point and say, okay, what is the plug pipeline look like at this point in the code when things can be added,
This is a two-part answer. For one, you want to implement an inspect protocol, for example, to hide implementation details, so you can use IO inspect more easily and look into the token. And for the question, what is the struct looking like at each point in time, I would refer you to Credo's source code, because Credo also follows this approach. And if you use mix credo --debug, you get all the output of what the stuff looks like at any given point in time.
Sorry, so say I wanted to know which modules were on deck to be executed, I guess, but as added by the step macro. So I can definitely look at the shape of the token at any given point. But if I want to see, okay, for this, if I'm here, what is that module attribute that I've accumulated all of these different step things that implement call? How many of those do I have, and what order are they going to be called?
So
Does that make
basically,
sense?
do you mean inspecting the pipeline to see
Yeah,
what
yeah.
will be executed?
That's right.
Well, you have all the information in the pipeline if you start building it, and then you would simply implement, I guess, something like the inspect protocol for that module, so that you can list them out.
There's no more time for
Yeah,
any more questions.
we definitely have to eat.